In this video, we're going to explore how to solve word problems that involve using proportions. Our first step in solving a given problem that involves proportions is to first identify our two ratios. Now, I notice the first ratio given should ideally have two values that are known. So, in other words, the first ratio is going to compare two things to each other. They're going to tell us exactly what those two different values are. Essentially, I can think of this as like a baseline. I need to have somewhere to go from. So for instance, someone might be able to say that 4 apples cost $5. I have somewhere to go with. I have a general idea about some number of apples for some number of money. We can then use this and look at the second ratio. So we're then going to look for the second ratio. This is the ratio that is going to have an unknown value. And we can call this some variable like x. So again, we're going to look for that first ratio, everything's given. Then we're going to look for a second ratio where one thing is given, the other is unknown. But we're then going to be able to do in this third step is set these ratios equal to each other and then make a proportion. Then once we have the proportion set, we can then solve the proportion just like we have in our past problems. So here's our first problem, and I'm going to go straight through the word problem trying to identify first a ratio where I know both values, then a second ratio where I know one value, don't know the second. So if I read, it says first, if you can buy 7 oranges with $3, and there's my key thing. 7 oranges is my first value, so I have a given amount of oranges. And my question now is, well, I have an amount of oranges. Do I have an amount of dollars that I can relate this to? And the answer is yes. I can buy 7 oranges with $3. So here's our first ratio. 7 oranges compared to $3. I know everything, the number of oranges and the number of dollars. This is a good baseline. Now I want to find a second ratio where I know one amount, don't know the other. So it's now asking how many oranges. So when it's saying how many oranges, my implication, how many oranges, is that I don't know how many oranges. This is what we're trying to solve. So I'm going to put X on the top, X oranges here. I don't know how many oranges. Now, how much is this unknown value being compared to? Well, they want to know exactly how many oranges we can buy with $9, so I can compare X oranges to $9. Now, one thing I want to emphasize here that is very important, it doesn't really matter how I set up the first proportion. I chose to put oranges on the top and dollars on the bottom, but once I set it up with oranges on top and dollars on the bottom, I have to be consistent, so I have to continue to set oranges on the top and dollars on the bottom in order for this to be a true proportion. Okay. So I have my two ratios. One I know is 7 oranges for every $3. The second I don't know, some number of oranges for $9. Now that I have these two ratios, I can set a proportion by setting these equal to each other. Or in other words, I can say that 7 over 3, our first ratio, is equal to X over 9, our second ratio, where X is our number of oranges that I can buy with $9. So now to solve this, I simply need to cross multiply. First, 7 times 9 is going to give me 63. And then if I cross multiply 3 times x, this gives me 3x. And now we've almost solved. All I need to do is apply the inverse of multiplication by 3. And I find that our value x is 21. And keep in mind that this 21 is representing a specific value. It's representing our number of oranges. So I do want to say 21 oranges. In our second example, we're asking about how many square feet we can paint with a given number of gallons of paint. So we're going to start through our word problem. It says, if you can paint 150 square feet with 4 gallons of paint. So there's my first given ratio. if I start talking about 150 square feet, or in other words, feet squared, well, the question is, how many gallons of paint did I need to paint this 150 square feet? Well, I can see that it was 4 gallons. There's my first ratio where I know everything. Now I want to see, well, what am I trying to solve for? If I keep reading, it says approximately how many square feet. So, how many, sounds like an unknown variable x, how many feet squared, or square feet, can you paint with 7 gallons of paint? So there's my second known value, 7 gallons. Now again, just to emphasize, I put square feet on the top in my first ratio, so I put square feet on the top in the second ratio. I put gallons on the bottom in the first ratio, so I put gallons on the bottom in the second ratio. So now that I have these two ratios, I can now set them equal to each other as a proportion. So I can say 150 over 4 is equal to x over 7. And now to solve for x, I'm going to solve like I would for any other proportion. I'm going to cross multiply. So if I do 150 times 7, gives us a pretty big number. That looks like that's going to be 1,050. And then cross multiplying here, I'm going to get 4 times x. So now to solve for our unknown x number of feet squared, I simply need to apply the inverse of multiplication by 4, which is division. 4's are going to divide to 1, and now I can simply simplify 1050 divided by 4, and it looks like we get that x is equal to approximately 262.5. And don't forget what we're talking about here. This is in terms of feet squared. In our third example, now we're talking about currency exchange rates. It says John learns that the current exchange rate is 14 US dollars for 11 euros. So there's our first ratio. 14 US dollars. So I'm just going to say 14 US compared to 11 euros. So over 11 euros. And again, it doesn't really matter which one I put on top or on bottom. I'm just recognizing that I have this current rate of 14 US dollars to 11 euros. Now the question, and when I need to use this ratio to help me solve, is approximately how many US dollars. So again, how many US dollars is another way of saying some unknown number, x, of US, would he need to trade to get 27? So how many US do we need to get 27? See that here, 27 euros. And again, just for emphasis, I see that all the US dollars are on the top, all the euros are on the bottom in order to keep consistency in these ratios. So now, to solve this proportion, I can first write the two ratios, 14 over 11 equal to x over 27. I can solve for x like I would any other proportion by simply cross multiplying. First, 14 times 27 gives me 378. And then if I cross multiply 11 and x, this gives me 11x. So now to solve for x, I can divide both sides by 11. So if I do 378 divided by 11, it looks like x comes out to be approximately 34.36 about. So 34.36. And keep in mind, we're talking about how many US dollars I would need. So I can say I would need 34.36 US dollars. Always good to label what unit we were finding to really make sure we are clear on what it is we're solving for. And this makes sense. Notice back here, I needed more dollars than I did euros, 14 versus 11. So it makes sense that 34.36 will be larger than 27 if I need to get 27 euros. In our last word problem, we're talking about changing the scale of a painting. It says here that Phil reduces the height of a painting to 4 inches. while keeping the overall scale of the painting the same. So all I know so far is that the height of his new painting is 4 inches. So let's just write this out. I'm going to say height of 4 inches. I'm just going to write what we know. What then goes on to say is, what is the new width? So we basically are saying, well, there's some height that's being compared to some unknown width. And I know that these are being compared because it says he reduced the height of a painting to 4 inches. So this 4 inches is its new height. Now it's asking what the new width is. I'm going to call this new unknown width x inches. Okay, so a little bit different. They actually gave us the unknown ratio first here. New height of the painting is reduced to 4 inches. The new width we want to know. Well, what are we going to use to figure this out? If I keep going, it says, what is the new width of the painting if it was originally 8.5 inches tall? So there's our original height. So our original height was 8.5 inches over, and if I keep reading, 11 inches wide was the original width. So I can say that the original width is right here as 11 inches. And now I have my proportion. Again, noticing both of these ratios have the height on the top. Both of these ratios have the width on the bottom. So now when I set them equal to each other, 4 over x equals to 8.5 over 11, I now have a solvable proportion here. So if I cross multiply, first 4 times 11, that's going to give us 44, equal to, cross multiply x times 8.5 gives us 8.5x. So now to solve for x, I'm going to divide both sides by 8.5, applying the inverse of the multiplication. And those cancel, leaving me with x is equal to, well, I have to divide 44 by 8.5, which turns out to be about 5.17 inches. And it's worth noting here that the 5.17 is the new width. And again, just to make sure that this makes sense, if I look at the original height 8.5 was less than the original width. So it makes sense that our new height 4 is less than our new width of 5.17 if I want to keep the general scale, or in other words here, the overall scale the same, which we say that the word problem here does specify. So now there are 4 word problems that I'd like you to try on your own, and then we'll take a look at this next class with some more practice.